Fast and light travel continues to be a fascinating but elusive concept in our ambition to colonize the cosmos. Einstein's theory of relativity states that the universe can move no faster than the speed of light, which is a fixed 299,792 kilometers per second. It is a towering barrier that is intimidating to our aspirations of intergalactic travel. In this video, we'll examine 10 theoretical approaches that break through this barrier, from exotic matter to quantum physics to time travel, to offer exciting possibilities for travel beyond the speed of light. What are the top 10 ideas for faster than light travel that will blow your mind? You will get to know this and plenty more as we dive into the details of today's show. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. Number 1, warp drive. In order to travel faster than the speed of light, FTL, warp drives, which are famously depicted in science fiction series like Star Trek, stretch the very fabric of space-time. But does it draw from science truth, or is it simply science fiction? The universe is not static, but dynamic, according to Albert Einstein's theory of general relativity, where big objects induce a distortion in space-time that gives the appearance of gravity. This raises the intriguing question of whether we could manipulate space-time if matter could do so. Miguel Alcubierre, a Mexican theoretical physicist, put up a mathematical model for such a notion in 1994. Its current name, the Alcubierre drive, alludes to the concept of a warp bubble. A spacecraft stays stable in relation to its immediate surroundings inside this bubble. On the other hand, space-time is bent around the vehicle. It contracts in front and expands in back. Despite without technically breaching the light speed limit or breaking the laws of physics, this enables this vehicle to go from point A to point B faster than the speed of light could do in ordinary space. The idea operates on a similar premise to a moving walkway in an airport. While the spaceship can stop moving while you are on the walkway, you can cover the distance more quickly than by walking. Alcubierre Air Drive does provide some monumental difficulties, though. It is not yet known whether such matter really exists, but it first requires negative energy or exotic matter, a theorized substance having features that defy the laws of energy. Second, the energy requirements are enormous, possibly equal to a planet's or even a star's mass energy. Additionally, problems like possible causality violations, time paradoxes, and enormous tidal forces that might wipe out destinations before arrival crop up. The spacecraft might also be imprisoned inside the war bubble. If it were to be released, high-energy particles might be released, which could be dangerous. Nevertheless, despite these difficulties, research into warp drive technology continues, motivated by the alluring prospect of traveling impossibly long distances in a single instant. A glimmer of optimism comes from recent advances in quantum physics and research into dark energy and exotic materials. But the warp drive may one day go from science fiction to reality. Number 2, wormholes. Wormholes are thought to be shortcut tunnels connecting far-off places of the universe on the great cosmic highway. If they do, they could allow for interstellar or even intergalactic travel within the lifespan of a person by exceeding the speed of light. In situations where the warping of space-time by mass and energy could result in a tunnel connecting two places, wormholes appear from the equations of general relativity. Imagine a piece of paper that represents the fabric of space-time. Normally, crossing the entire surface to get from one side to the other would be necessary. However, if the paper is folded over, bringing 2 points together, and a hole is constructed connecting them, you get a streamlined representation of a wormhole. Wormholes actually refer to travelable passageways through the fourth dimension that connect at two locations in three-dimensional space. It appears as though we have jumped from one location to another instantly from our three-dimensional vantage point. The speed of light hasn't been exceeded inside the 4 dimensions of space and time, despite appearing to do so. However, this intriguing idea of stability comes with a big drawback. Any naturally occurring wormhole would be incredibly unstable and collapse right away, according to general relativity. Some kind of unusual stuff with a negative energy density or negative pressure would be necessary to keep a wormhole open. There is kernel. Number 3, quantum entanglement, entangled quantum states. One of quantum mechanics' strangest events suggests a path for instantaneous communication that appears to defy the speed of light. This phenomenon happens when 2 or more particles get entangled in such a way that their states are instantly influenced by one another, regardless of how far apart they are. In a 1935 publication, Albert Einstein, Boris Podolsky, and Nathan Rosen made the first mention of quantum entanglement. As it appeared to contradict Einstein's theory of relativity, which holds that nothing can travel faster than light, not even information, he famously referred to it as spooky action at a distance. Nevertheless, despite his doubts, Bell's inequality tests have empirically supported quantum entanglement, which is today a well-established aspect of quantum theory. Entanglement might theoretically be used for quantum teleportation or faster than light communication. For example, 2 parties may share a pair of entangled particles, where any change to one particle's state would immediately reflect in its entangled partner, acting as a medium for instantaneous information transmission across any distance. The use of quantum entanglement for faster-than-light transport or communication does face some serious challenges, despite its alluring potential. First and foremost, it's crucial to grasp that entanglement doesn't include the transmission of conventional information. According to quantum theory, a link does not correlate to readable information until it is tested, and the results seem random. So you can't transmit significant information since you can't control the state you're communicating. Second, even if we were able to manipulate quantum states, any attempt to observe or influence a quantum system typically causes decoherence or the collapse of entanglement. It is extremely difficult to sustain stable, long-range entanglement and accurately measure entangled particles. Last but not least, the no communication theorem in quantum mechanics asserts that it is impossible to communicate classical information via a quantum channel alone, even if these problems were resolved. Consequently, despite the fact that quantum entanglement offers intriguing new avenues for unraveling the mystifying nature of the quantum world and has useful applications in quantum computing and encryption, it is exceedingly improbable that it will ever be used for faster-than-light transit or communication. Number 4, Alcubierre drive. A fascinating idea in the field of faster-than-light travel is the Alcubierre drive, put out by theoretical physicist Miguel Alcubierre. This hypothetical propulsion system which bears the name of its inventor and is based on the general relativity theories of Einstein, claims to be able to travel faster than the speed of light. In essence, the Alcubierre drive involves enclosing a spaceship in a space-time bubble. The idea makes use of Einstein's field equations' description of spacetime's flexibility. The engine expands spacetime behind the spaceship, while tracking it in front, thereby building a wave on which the spaceship can ride. As a result, the spacecraft could travel through unwarped space faster than the speed of light without breaking any of the laws of physics or going faster than light locally. Importantly, time dilation and extreme acceleration wouldn't affect the spaceship or anything on board, keeping everything inside of it in a state of free fallout. Regardless of the distance traveled, passengers would view the journeys as happening instantly or in a very short amount of time. The Alcubierre road faces several severe obstacles despite its promise. Its theoretical operation primarily calls upon negative energy or exotic matter, a kind of stuff whose existence has not been verified by scientific evidence. Exotic matter includes characteristics like negative mass and might defy a number of energy constraints, raising doubts regarding its compliance with accepted physical principles. Even if the exotic matter does exist, the Alcubierre drive's proposed energy requirements are so great that they could theoretically be used to completely transform the mass of a planet or star into energy. Additionally, new research points to potential issues such as the building of high-energy particles in the front of the bubble and the inability to maneuver or halt the drive after it has been turned on. Furthermore, Alcubierre's hypothetical operation might lead to causality errors that result in time travel paradoxes and raise significant doubts about our perception of reality. It's important to remember that the Alcubierre drive is currently only a theoretical idea, with no experimental support or technological prototype. However, since it was first proposed, there has been a lot of interest in the scientific community, which has led to new developments in the fields of exotic matter, quantum field theory, and general relativity. Number 9. Exotic matter, exotic subject. Theories of travel at speeds faster than the speed of light have a unique place for a term that encompasses forms of stuff that defy our common understanding. Exotic refers to any kind of matter with characteristics not found in the common matter we encounter. It does not specifically relate to any one kind of matter. Exotic matter is required in theories of travel at speeds greater than the speed of light, which is a recurring theme. In the equations of general relativity, strange, exotic stuff with odd properties, such negative mass or negative energy density, frequently appears. The theoretical frameworks of the Alcubierre drive and traversable wormholes correspond with the most well-known examples of unusual materials' prospective applications. In the Alcubierre drive, a spaceship can successfully travel faster than light by surfing a wave of space-time in a space-time bubble that was formed and maintained by exotic matter. Similar to wormholes, exotic matter is needed to prevent wormholes from collapsing naturally, allowing for the possibility of using them as cosmic shortcuts. Even though weird matter is mathematically possible, its actual existence and characteristics are still hotly contested. There is currently no compelling experimental proof of the existence of exotic matter. The ramifications of unusual masses could also be problematic for theoretical physics. Its existence might go against multiple energy laws, resulting in theoretical contradictions and paradoxical situations like perpetual motion and time travel. Finally, even if exotic matter does exist, Manipulating it with the size and accuracy needed for faster-than-light propulsion offers a significant technological challenge that is well beyond our current capacity. However, despite these considerable obstacles, the study of exotic matter provides a useful way to expand our knowledge. Its research promises to shed light on the nature of the cosmos, the unification of its fundamental forces, and the interaction between quantum physics and general relativity, in addition to perhaps advancing propulsion technology. Do let us know your thoughts and opinions in the comments section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching. We hope to see you at the next one.